Hello, student. I welcome you all in online lecture series. I'm Dr. Ganesh Mogal, Assistant Professor, Department of Physics, KTHM College, Nasik. Friends, we are discussing about the radioactivity from nuclear physics. We know that there is a spontaneous emission of a radiation from a radioactive element, and this property is known as radioactivity. Here in previous lecture we discussed about the properties of alpha particle, beta particle and gamma radiation. Alpha particle is also known as a helium nuclei, while beta particle is electron and gamma radiation is the electromagnetic wave. In this lecture, we have to see law of a radioactive decay. So, there is a disintegration of a radioactive element, and the rate of disintegration is always equal to number of radioactive nuclei present at that instant. So, law of a radioactive decay. Law of radioactive decay. Statement is the rate of a disintegration of a radioactive element or a radioactive nuclei. The rate of disintegration of radioactive nuclei is always equal to or simply we can say that the rate of disintegration of radioactive nuclei is directly proportional to its directly proportional to number of radioactive nuclei of radioactive nuclei present at that instant. So our law is the rate of disintegration of a radioactive nuclei is directly proportional to number of radioactive nuclei present at that instant, and therefore we can say that minus dn upon dt is directly proportional to n. Here negative sign indicate that the radioactive nuclei are disintegrate. Dn is number of radioactive nuclei disintegrate in a time dt, where n is the number of radioactive nuclei present at a time t. Okay? Therefore, this can be also written as minus dn upon dt, it is equal to lambda into n, where lambda is a proportionality constant known as decay constant or disintegration constant. Lambda is a proportionality constant known as decay constant or disintegration constant. Here the definition of a decay constant or disintegration constant is Lambda is equal to minus dn upon dt divided by n. Therefore, the disintegration constant or a decay constant can be defined as it is a ratio of number of radioactive nuclei disintegrate per unit of time to number of radioactive nuclei present at that instant. Okay. So, lambda is equal to minus dn upon dt. This represent the number of radioactive nuclei disintegrate per unit time, and n represent number of radioactive nuclei present at that instant. Okay. So, this is a decay constant or disintegration constant. This can be also written as dn upon dt, it is equal to minus lambda into n. Dn upon dt, it is equal to minus lambda into n. Okay. This equation can be also written as dn upon n, it is equal to minus lambda into dt. Dn upon n, it is equal to minus lambda into dt. Taking integration on both sides, taking integration on both sides, we get integration of dn upon n, it is equal to integration of minus lambda into dt. Okay. Here integration of dn upon n is ln of n, and integration of minus lambda into dt is minus lambda into t plus c, where c is a constant of integration, where c is constant of integration. Okay. C is a constant of a integration. This equation is considered as equation number 1. Okay. Now, if we consider t is equal to 0, okay, that is a time t is equal to 0, the number of radioactive nuclei are not disintegrate. Therefore, at an initial time, n is considered as n0. Okay, that is the original number of radioactive nuclei. The radioactive nuclei are not disintegrate when t is equal to 0. Okay, and therefore equation 1 became ln of n0, it is equal to, here t is equal to 0, therefore minus lambda into 0, it is equal to 0, it is equal to c. Okay, ln of n0 is equal to c. Putting this value in equation 1, putting this value in equation 1, we get ln of n is equal to minus lambda into t plus value of c is a ln of n0. Okay. This equation can be also written as ln of n minus ln of n0, it is equal to minus lambda into t. So, This can be also written as ln of n upon n0, it is equal to minus lambda into t. Here is a ln at the left side. When it goes to the right side, it became exponential, and therefore we can write n upon n0, it is equal to e raised to minus lambda into t, and therefore n is equal to n0 e raised to minus lambda into t. This represent the equation of radioactive decay. This equation consists of the exponential term, and therefore we can say that the radioactive nuclei disintegrates exponentially with the time. Radioactive nuclei disintegrate exponentially with the time. And when we plot a graph of the number of radioactive nuclei versus time t, here x-axis time t and y-axis number of radioactive nuclei. Okay, n means number of radioactive nuclei. We know that when time t is equal to 0, number of radioactive nuclei are n0, and therefore here when time t is 0, number of radioactive nuclei is a n0. Now this number of radioactive nuclei disintegrate exponentially with the time, and therefore graph is like this. Okay, if we consider when time is a t, time is a t, number of radioactive nuclei consider as n. Okay, number of radioactive nuclei consider as a n. If we consider time is increases here dt. Okay, here is a dt, so it is a t plus a dt. Okay, then the radioactive nuclei disintegrate, that is n minus dn, n minus dn. So this represent number of radioactive nuclei disintegrate. dn is a number of radioactive nuclei disintegrate in a time dt, and therefore we can represent this minus dn upon dt. Okay, and from this graph we can say that the radioactive nuclei are exponentially decay with the time. Okay, if we consider here the decay constant d is equal to reciprocal of a time period, reciprocal of a time, that is lambda is equal to 1 upon t, and therefore we can say that n is equal to n0 e raised to minus 1 upon t into t. So it is minus 1, and therefore we can say that n upon n0, it is equal to e raised to minus 1, e raised to minus 1. Okay, so this can be also written as n upon n0, it is equal to 1 upon e, 1 upon e. Here value of e we can represent like this, n upon n0, it is equal to value of e is a 2.718. Value of e is a 2.718. So n upon n0, it is equal to 0.36. Okay, 36, and therefore we can also write n upon n0, it is equal to 36%, or n is equal to 36% of n0. And from this we can say that if the decay constant is a reciprocal of a time, then the number of radioactive nuclei remain 36% of its original value. If decay constant is reciprocal of a time, then the number of radioactive nuclei remain 36% of its original value. So this is related to law of radioactive decay. Law of radioactive decay is the rate of disintegration is directly proportional to number of radioactive nuclei present at that instant, and therefore we can say that minus dn upon dt is directly proportional to n. Here negative sign indicate that the radioactive nuclei are disintegrate per unit time, and therefore we can say that minus dn upon n, it is equal to lambda into n, where lambda is proportionality constant known as a decay constant or a disintegration constant. Here lambda is equal to minus dn upon dt divided by n, and therefore decay constant or disintegration constant is defined as it is a ratio of number of radioactive nuclei disintegrate per unit time to number of radioactive nuclei present at that instant. Okay, so this is a decay constant, and therefore we can say that dn upon dt is equal to minus lambda into n. This equation can be also written as dn upon n is equal to minus lambda into dt. Taking integration on both sides, we get integration of dn upon n, it is equal to integration of minus lambda into dt. Integration of dn upon n, it is equal to ln of n, and integration of minus lambda into dt is minus lambda into c into t plus c, where c is a constant of integration. If we consider when time t is equal to 0, that is the initial time, the number of radioactive nuclei n is equal to n0. There is a no disintegration of a radioactive nuclei, and therefore we can say that ln of n0, it is equal to c. Putting this value in equation 1, we get ln of n is equal to minus lambda into t plus ln of n0. This equation can be also written as ln of n minus ln of n0 is equal to minus lambda into t. Therefore ln of n upon n0 it is equal to minus lambda into t, and therefore n upon n0 is equal to e raised to minus lambda into t. Therefore n is equal to n0 e raised to minus lambda into t. This is the equation of radioactive decay, and from this equation we can say that the radioactive nuclei are disintegrate exponentially with the time, because this equation consists of the exponential term. Now if we consider lambda is equal to 1 upon t, then n is equal to n0 e raised to minus 1 upon t into t, t get cancelled, so it is equal to e raised to minus 1. So n upon n0 is equal to 1 upon e. Value of e is 2.718, and therefore n upon n0 is equal to 0.36, or simply we can represent n upon n0 is equal to 36%, or n is equal to 36% of n0. If the decay constant is a reciprocal of a time, then the number of radioactive nuclei disintegrate 36% of its original value. Okay, so this is related to law of radioactive decay. In next lecture we have to see what is the activity, what is the half-life of a radioactive substance. Thank you.